Hello everyone, I am Pankaj Singh welcoming all of you on Drishti online platform of the 100 most important topic, this geography 2020 and the sixth episode. And before starting the sixth episode, I have to do some questions which I have given in the fifth episode. So the questions which are based on, I can say like continental shelf, abyssal plain, oceanic range, and it is Atlantic meridional overturning circulation, climate impact of warm ocean current and climate impact of cold ocean. So here we can be able to see that first question with reference to the continental shelf, consider the following statement. And here it is the shallowest part of the ocean floor adjoining the land mass. And this is the statement on the basis of continental shelf again. It is the shallowest part of the ocean floor adjoining the land mass. It has a steep slope. And second statement, it has a steep slope and ends abruptly at a greater ocean depth. The first statement, if you are talking about, it is the shallowest part of the ocean floor adjoining the land mass. Yes, the continental shelf, you can say that it is around average depth is around 200 meter. And if you want to make it clear, earlier in the classes that we have done, so please go and check it out. And here the first statement is correct. Second, it has a steeper slopes and ends abruptly at a greater ocean depth. No, its only average depth is 200 meter. And here it is in a water flat kind of it. Its slope is with 2.5 degree or something like that. So this option, it has a steep slope. So this is on the basis of that, it is in a wrong statement. It is rich in marine resources such as fish and hydrocarbons. Yes, this is the correct statement. And because lots of what can say that different kind of gas hydrates, petroleum, crude oil, and shale gas, most of the things which are found in this region. So it is rich in fish and hydrocarbons. So 1 and 3, option C is correct. So that next question we are going to see, consider the following statement regarding abyssal plain. Abyssal plain is the deep sea. Abyssal plain is the deep sea plain, and they are covered with fine sediments like clay and silt. First statement, it is a fine, yes, it is the deepest part of the ocean, and it is in a clay, it is in a deposited with the clay and silt. And this statement is correct for the abyssal plain, and they are found near mid-oceanic ridge only. No, it is found between, I said that there is a mid-oceanic ridge in the middle, mid-oceanic ridge, and at the same time between the continental rise. This is the continental rise. So not only near to the mid-oceanic ridge, it is lying between mid-oceanic ridge and continental rise. So this statement they found near mid-oceanic ridge only. This statement is wrong. They may contain polymetallic nodules. Yes, they contain some sulfide, some manganese, this kind of phosphoric, some iron, polymetallic nodules are there. So we can say that this statement is correct. Again, we can say that option A, 1 and 3 only is correct. Now let us see the next question. With reference to the oceanic range, consider the following statements. And the first statement that we are seeing, they represent the shallow part of the ocean floor. So that is what oceanic range is, not the shallowest, it is the deepest part of the ocean floor. It is when you can be able to say that when the two oceanic floor going on, and there is in a water, this is the convergence of plates are taking place. This is the deepest part of the ocean that you can say. And so this statement, they represent the shallowest part of the ocean floor. It is a wrong one. They are associated with the subduction zone. Yes, when the plates are subducting below another plate, the denser plate is subducting below less denser plate, then in that case we can be able to say happen it is ocean convergence. During that subduction happen, and then ocean continental convergence. During that you can say subduction takes place, and then all the time when the subduction is taking place, oceanic ranges will form. So they are associated with the subduction zone. This statement is correct. And they are often sites of intense seismic activity. Yes, when the plates are moving inside it, so there in this region there is a Benioff zone is there, and it has a high earthquake zone here. So it is associated with the intense seismic activity. So this statement is also correct, and on the basis of that, option B and 3 only is correct. Now if we have to talk about it is with reference to the Atlantic meridional overturning circulation. Yes, it is consider the following statement. It involves northward movement of warm surface water. Yes, it is the northward movement of warm surface water. Warm surface water moves northward and from the equator to pole, and southward flow of what cold deep water in the near the what you can say in the polar region nearby. That cold water moves downward, descend downward, convect downward, and in the deeper region from the pole to the equator and the southward it turns. Then it is a correct one. And if you have any kind of problem, you can go and see the last 5th episode. It will be very much important for you. And another point I am saying that second statement, it is driven primarily by the difference in temperature and salinity of ocean water. Yes, temperature and salinity of ocean water changes the depth of the ocean. Where the salinity is higher, the level of water is down, and where the salinity of the ocean is less, level of water is up. So that's what happened, that there is a movement of ocean current is taking place, and as well as the temperature is also making an important role. So the temperature is very colder one, you can say that it will be a compressed one, and the temperature is a warmer one, ocean, it will be a larger one, and then it has an expanded comparatively. And as well as you can be able to say that in the temperature, if the temperature is more, it is, I said that in that condition, the expansion of thermal expansion, you can say that the level of water is more. So we can say it is driven primarily by the difference in the temperature and salinity of ocean water. So yes, it is also correct. It operates only in the Pacific Ocean. No, it is an Atlantic Ocean and all. So it's not only in that. So it is in a wrong one. So we can say that option A, 1 and 2 only is correct. And next one, with reference to the warm ocean current, consider the following statement. Warm currents generally increases temperature and humidity of adjacent coastal area. Yes, warm current increases the humidity in the coastal area, because the warm current is producing more moisture into the coastal area, and that helps in the increasing in the humidity. So this statement is correct. Second statement, warm currents are often associated with the arid coastal climates. No, because of the warm ocean current, if it is moving along the coastal area, they create more moisture and the coastal area will have a rainfall. Is it okay? Cold ocean current, if it is flowing, then there will be an arid climates can be there. So warm currents are often associated with the arid coastal climate and desert. No, it's a wrong one. And warm currents reduces marine productivity by limiting the nutrient availability relative to cold current. Yes, cold current has relatively more nutrients into the water, and in comparison to what I said, that warm ocean current. So here this statement is what I said that correct. So we can say the statement 1 and 3 only is what correct. So the next part that we are going to see here, consider the following statement regarding cold ocean current. And the first statement, the Labrador current is a cold current flowing southward. Yes, this is right statement. And the meeting of warm and cold currents can lead to a fog formation and rich fishing grounds. Yes, it helps in the fog formation in the northeast of North America. When cold Labrador current and Gulf Stream is meeting in that region, there is a fog formation, and then large amount of nutrients come, therefore it is in a fishing ground. So this statement is also correct. And then cold currents are generally associated with the nutrient rich upwelling zones. Yeah, yes, if the cold current is there in the coastal area, there is an upwelling of what cold water is there, and from the below, and then from the below nutrients comes up, and then you can say that yes, this statement is also correct, and we can say that option D, 1, 2 and 3 all are correct. After that, we are going to see in this 6th episode, we have to do, like I said, that marine salinity. We have to do marine salinity, Equatorial Low Salinity Zone, and then we'll see Subtropical High Salinity Zone, vertical distribution of salinity. So these are, I said that Equatorial Low Salinity, Subtropical, this is, we can be able to say that it is in a horizontal, it is in a considered as a horizontal distribution of salinity. Is it okay? And then vertical distribution of salinity, and we'll see factors affecting salinity, horizontal distribution of ocean temperature, and vertical distribution of ocean temperature, factors affecting ocean density. These are the things that we have to do in this episode of 6th episode. So here it is talking about the first one. We have to talk about marine salinity. Salinity means, I said that amount of salt in 1 kg of water. Amount of salt in 1 kg of water, and in the ocean I said there is a 35 gram salt. There is a 35 gram salt in 1 kg of water means 1000 gram, and that is written as 35 parts per thousand. So it is written like that, and then ocean salinity is 35 parts per thousand. In this one, the highest amount is contributed by, I say that sodium based chloride. You can say that sodium chloride is the highest one, and then after that again chloride ion is always the highest. Chloride ions is highest one, and now sodium chloride it is around 77.7% you can say, and magnesium again after the chloride, magnesium chloride it is around 10.9, you can say that 10.9 percent of the total salinity, and thereafter you can say that magnesium chloride, after that again magnesium, it is magnesium sulfate, it is 4.7%, after that 7, then there is a 6, 3.6%, and after the 6 there is a 5, and this is calcium sulfate I am talking about, 3.6, and potassium sulfate it is what 6, after that 5, it is 2.5%. So you can say that sodium chloride it is 77.7%. Little bit sometimes in the UPSC can ask such kind of questions, so we can be able to say yes, magnesium sodium chloride 77.7%, magnesium chloride it is 10.9%. after that it is in a very easy sulfate related is there, magnesium sulfate you can say that there is a 4.7%, and there is a calcium sulfate, all are sulfate last three, calcium sulfate it is 3.6%, potassium sulfate 2.5%. if it has been asked which one is higher, which one is lower, it is not going to ask the percentage, but with the help of that it will be very helpful for you in answering the. So, and there is a constant proportions means principle of constant proportion means in any, if we are talking about Pacific Ocean, if we are talking about Indian Ocean, if we are talking about Atlantic, if we are talking about Arabian Sea, where you are talking about any sea in the world, is sea or ocean, everywhere the proportion of this percentage it will remain the same. That whatever the salinity, sometimes in the ocean, sometimes salinity is increases. Sometimes somewhere 40 parts per thousand in the Mediterranean Sea, there is a 40 in Mediterranean Sea 39 parts per thousand, in the Red Sea it is around 40, and the Persian Gulf around 41 parts per thousand. Salinity some varies, but proportion, it will be proportion remain the same, 77.7%, there is a 10.9%, 4.7%, 3.6%, 0.5%, it will remain the same. So here you can be able to say that in this region, this kind of condition you can be able to see. Now the question based on this one, just we have to answer this question, we have to answer in your, I said that comment box, and we will see. Even if you have any kind of doubts you can ask, but again I am telling you, if you have any doubts please ask, and we are ready to answer. The first one, I said that sodium chloride constitute the largest proportion of dissolved salts in the seawater. Recently I have done something, yes or not? So please check it out and read it properly. The questions will coming from that. That second statement is talking about the principle of constant composition. State that the relative proportion of major salts in seawater remain nearly constant. Yes, again you have to say that whether it is right or wrong. Magnesium sulfate is present in greater proportion to that magnesium chloride in the seawater. So these three statements you have to see, and you have to answer it. Now we are moving to the next. It is, I said that horizontal distribution of ocean salinity. In this one we have to say that it is an equatorial low salinity zone we have to see, and thereafter we have to see, like I said, that subtropical one, and then we will see polar salinity zone. These are the three that we have to see. It is about, I said that for horizontal distribution of what salinity of ocean. So if I am talking about the horizontal distribution of salinity of the ocean, here we can say like if I am talking about horizontal distribution, here there is this is an equatorial low zone, equatorial low pressure zone. It is an equatorial low pressure zone. Here is a subtropical high pressure zone, and there is there is some subpolar also, but a subpolar low pressure zone is there. And there is a polar high pressure zone is there also. Polar high pressure, subpolar low pressure, there is a subtropical high pressure, and it is an equatorial. Similarly in the southern hemisphere also. Yes or not? Similarly here also. Similarly here also. In the equatorial low pressure, salinity of the ocean is generally, you can be able to say that it is decreasing. in the why it is what I say that in equatorial region every day up to the 12 p.m. because of the what cloud formation, heavy rainfall is taking place, and because of that the salinity will be, I say, and cloud formation, and after certain period cloud forms, then the evaporation. One, that is in a cloud formation, good amount of rainfall, mixing of fresh water. Mixing of fresh water reduces salinity. If fresh water adding, then suppose in this water there is a 35 gram, in 1 kg 35 gram suppose salt is there, but now it becomes 2 kg if fresh water we have added. So when you are adding 2 kg, so 2 kg has what I said, that fresh water, so 2 kg has what 35 means 35, and then 2 kg divides 17.5 gram salinity. So if you are adding fresh water, it will be salinity will increase, and if evaporation is more, suppose 2 kg has 70 gram salt, and 1 kg evaporated, now 1 kg has an you can say that 70 gram salt. So if evaporation is there, that the salinity increases, rainfall is there, then it is, I say, that salinity is reducing. So we can be able to say that that evaporation, if it is not happening, salinity will be less, and the rainfall will happening, salinity will be here. In equatorial region, every day 12 to 2 p.m. there is a formation of cloud, and then cloud, and the 2 to 4 p.m. rainfall occurs. So rainfall is occurring, and therefore salinity is less, and because of the cloud is upper atmosphere is saturated with the cloud, so therefore after 12 p.m. there is no evaporation takes place. Evaporation is also very less after that. So we can be able to say that when the air is saturated, then there will be a less evaporation. So here you can be able to say that salinity will be less because of the rainwater. So the same thing from the equatorial, subtropicals, and then polar, high pressure. In this region we'll show our horizontal distribution of salinity, and here we can say that in this horizontal distribution of salinity, here we can say like the salinity is around 34 to 30, salinity is around, you can say, 34 to 35 parts per thousand. How much, what is the salinity we can say? 34 to 35%, and 34 to 35 parts per thousand. It is less than the original salinity of the ocean. It is less than the original salinity of the ocean. Why it is less? Because of the reasons, heavy rainfall every day, there is along the ITCZ is there also, and then heavy rainfall, cloud cover reduces evaporation. If there is a cloud coverage is there, the evaporation will reduce. So this is the what you can say that regions are there, it is 34 to 35 parts per thousand in this region. Another what I said that key features include heavy rainfall lowering the salinity by diluting surface water, and then cloud cover. This is a cloud cover suppressing evaporation. If the cloud is there, then the evaporation stops, suppressing evaporation and preventing salinity from rising. So this is the one we have seen about the equatorial low salinity, and based on this there is a question. Consider the following statement: the equatorial region shows highest salinity values due to intense solar radiation and persistent cloud cover. That the first statement, equatorial region shows highest salinity values due to intense solar radiation, and we can say that there is first statement we have to show. What is it? What do you think? What is it is right or wrong? Just give. If you have any problem, just watch the videos again, then write the answer. The equatorial region shows highest salinity values due to intense solar radiation. Yes, intense solar radiation is there, but you know that every day after 12 p.m. there is a cloud coverage, the solar radiation, what I said, that reduces after that. Another one I said that persistent cloud cover in the equatorial region reduces evaporation from the ocean surface. You have to see whether it is right or wrong. Another, freshwater input from rainfall plays a dominant role in determining salinity in this region. So please, we have done all this, and please accordingly answer this question. Okay. And another, horizontal distribution of salinity for the subtropical high pressure. So in the subtropical high pressure, what happens? We can be able to say that in this region, the air is to descend down. In this region, subtropical high pressure, that is in a 25 to 35, or you can say 20 to 30 degree latitude in the northern and southern hemisphere, that the air descend down. When the air descend down, it blocks the water vapor to move up, and there will be, I said that more heating is there. More heating, and then what I said that cloud formation will not take place. In this region, cloud formation does not take place, and then cloud formation, if it is not happening, so you can say that rainfall is very less. but because of the heating, evaporation is keep on happening, and you can say that in this region high evaporation and less rainfall. And because of the high evaporation in this region, you can say that evaporation is more, rainfall is very less. So we can be able to say the dry condition it is there, and therefore salinity in this region become 36 to 37 parts per thousand, and sometimes it is also written as 36.5 sometimes. So if it is written 36.5, even then it is what you can say that it is correct. Is it okay? So, and in the North Atlantic Sargasso Sea, you can be able to say in the nearby America, in the North Atlantic Sargasso Sea, it is coming under subtropical high pressure zone, and that is in a high what salinity. So what are the key features? Strong solar heating driving intense evaporation, means heating is more, and therefore you can say that evaporation is more, and the low rainfall and clear sky. Low rainfall and clear sky means there is no cloud formation is what I said that not there, so the clear sky, and because of that fresh water is not mixing, and if the fresh water is not mixing, it is the salinity will be. So this region has a more salinity. So what I said that consider the following statement regarding subtropical zone. This subtropical zone are characterized by higher salinity compared to equatorial region. Second statement, high evaporation and the low precipitation are the main causes of increased salinity. Yes, you have to say whether it is right or wrong, and please keep on giving comment whether these statements are right or wrong. Yes, we are waiting for your comments. And then I said that persistent cloud cover in these regions enhances salinity by trapping heat. So on the basis of this statement, give your answer, and we are waiting for your answer. Next one, another horizontal distribution in the polar region. In the polar, there is a low salinity zone. If we are talking about why it has a low salinity zone, first of all, here is the temperature is very less also, and over there you can say that ice melting. Ice is what I said that it completely provide fresh water, and ice melting provide fresh water. Because of the fresh water input, salinity decreases, and at the same time you can say that evaporation is also less, because in this region some kind of what moisture and covering of what I said that a little bit cloud and foggy condition is there. Therefore, there is an evaporation is also less. So what we can say that key feature, melting icebergs contributing fresh water to the ocean, and then fog and overcast sky. Sky is covered with the fog and other. Therefore, evaporation is also less. So indicating minimum solar driven evaporation. So this region has a very less. You can say that what I said, the salinity, and it can be from the what 31 to 32 parts per thousand, or it can be 30 to 32 sometimes if it is also written as this is the correct one. So here these are the reasons. Because of that you can be able to say that ice is what I said that melting and low evaporation. It is a major cause of I said that less salinity of the ocean in the polar region. We can say like when the Ganga and Brahmaputra river are meeting in the Bay of Bengal, in this region where it is meeting, so they are contributing large amount of fresh water, and because of the fresh water contribution, the salinity is reduces up to the what 10 to 20 parts per thousand. The average salinity of the ocean is what 35 parts per thousand, but at the river mouth where the river is meeting with the this one, so here you can say that in this region you can say that low salinity is near river mouths Ganga and Brahmaputra, Bay of Bengal, caused by fresh water influx from the rivers. The salinity is 10 to 20 parts per thousand. But if we are talking about between Africa and Europe, there is a Mediterranean Sea is there. In this Mediterranean Sea, there is an I said there is no, in this region the influx of the river water and other is very less comparatively, and I said that evaporation is also more. In this region, in the Mediterranean Sea, in the what Red Sea, in the Persian Gulf, the mixing of what river water, fresh water is less, input is less, but evaporation is more. So therefore, you can say that the salinity of in the Mediterranean Sea is around 39 to 40 parts per thousand. Red Sea, it is around 40 to 41 parts per thousand, and that is what in the Persian Gulf around 41. So you can say that in this region, not only in the Mediterranean Sea, this Red Sea and Persian Gulf has because of what high evaporation and limited fresh water input in this region, you can say that on an average 38 to 40 parts per thousand salinity you can be able to. So here Now we are going to see that is in a vertical distribution of salinity. Vertical distribution of salinity. Before starting this one, vertical distribution of salinity, we need to see like yes sir. Here, suppose in this this is in a depth of the ocean, and then there is a top surface is up to 0 to 200 meter, but some books is also talking about 0 to 500 meter. In this region, what is happening in this region from the top to the depth of the 200 and 500 meter, this is known as a surface zone. In this surface zone, what is happening? Actually, what is happening in this region, rainfall is happening, yes or not? Rainfall, and you can say that evaporation is happening in the different region, different rainfall, and at the same time I said that the sea waves are moving. So sea waves, you can say that because of that mixing, the top water is mixing with the down water, so that mixing is going on in this region, mixing surface. So it is sometimes it is also known as a mixing zone, surface zone. So in the top region, suppose if I am talking about if the ocean salinity in the equatorial region is 34 to 35 parts per thousand. So in this region 34 to 35, but if you are going to subtropical high pressure, there is in a 36 to 37 parts. If you are moving to the polar region, it is in a 31 to 32 parts per thousand. So every surface is different in the different region because of the rainfall. But if I am talking about only in equatorial zone, so there will be in a top, it will be 34 to 35 parts per thousand. So suppose I am talking about here, it is in a 35 parts per thousand. So on the top surface zone, it will be the salinity from the surface to the 500 meter or 200 meter depth, it will be same, and it is in a mixing zone because mixing, so the salinity will remain same. And if it is remains same, after that from the 200 to 1000 or 500 to 1000, after that suddenly there is a decline in what is salinity. So if it is, I said that 36 parts per thousand, so here it is reached up to what I said that 34, and then we can be able to say that is declining, and thereafter this is then after that remain constant. So this is in a rapid decline. This reason is what I said that rapid decline of salinity, and that is known as what I said that halocline. Halo means salt, and cline is related to what you can say that decline in rapid decline in what salinity. So it is known as a halocline, and after that it is in a deep sea. It is in a deep sea, you can say, and in the deep sea, it will, like, suppose on an average 4500 meter depth, it will remain same. So these are the three zones are there in the vertical. One, you can say that there is in a surface zone, there is in a halocline layer, surface layer or mixing layer, there is in a halocline layer, and deep sea. Is it okay? If I am talking about in equatorial region, this thing will be there. But if I'll go into the temperate and what I said that temperate region, in the colder region, temperate region, in this region, during only summer it will be visible, halocline, because during the winter what happens? During the winter the water become colder and start moving downward, so the halocline does not exist, because in the deep layer the current start. So in the winter, in the temperate zone or in the what I said that subpolar low subpolar region, in that region it will not exist, and in the polar region throughout the year, because the water is very cold, there is no, I said that such kind of layers you can be able to say. So here there is what I said that little bit exist, but even then we can say like here let us see about it. Here what is happening? So there is in the surface zone is 0 to 200 meter, or you can also say 500. It is the rainfall is happening, evaporation is there happening, and mixing is happening. And then salinity, you know that in the polar 30, and then some subtropical 36, 37. So in the surface zone it is like that. But if I am talking about halocline zone, it is the rapid salinity change with depth act as a barrier to the vertical mixing. So if I am talking about this halocline layer, so the water of this one is not able to mix with this. So halocline layer, this halocline layer does not causing mixing of this one to the water downwards. It is acting as a barrier, and then transition zone between the surface and deep layers. So it is in a transition zone between surface and the deep layers. Another is in a deep zone. It is in a stable salinity. In this region, salinity will remain the same. It will remain the same. It will keep on moving downward. And here we can say that is stable, a minimal variation due to the insulation from the surface, because there is constant, because it is not meeting with, you know that in the surface everything is happening, and this is not able to meet here because of this layer, because of the halocline layer. It is acting as a barrier, so that will be remain constant up to an extent. It is okay. In the whole ocean it will remain constant. So here I say that consider the following statement regarding vertical distribution of ocean salinity. The surface layer shows high variability in salinity due to factors like evaporation, precipitation, and wind-driven mixing. So please answer this. I think you are able to understand then what is happening at the surface zone. The halocline zone is characterized by uniform salinity with the depth. Yes, you have to check it out whether it is right or wrong. The deep zone has relatively stable salinity due to the limited or no influence from the surface process. So you have to say whether it is right or wrong, this statement, and just to give your answer accordingly, and I am waiting for your answers. And thereafter the next one, that factors affecting ocean salinity. I have already discussed evaporation. More evaporation, salinity will increase, yes or not? And in the region precipitation, rainfall is taking place, in this one salinity will reduce. River discharge, fresh water of river, yes, salinity decreases. And ocean current keep on mixing, redistribute the salinity. Ice formation, when the ice forms, when the ice is in the process of formation, they release salt. When the ice is in the process of formation in the Arctic and the nearby Antarctica, so when there is a formation, they release the salt from the water. So when they release the salt from the water, so the salt comes into the ocean, and then ocean salinity increases, and there is an ice formation. It is in a completely fresh. It's completely. So we can say that ice formation causing increase in salinity, and the ice melting, when the melting of ice melt, it will again, it will provide the fresh water, because ice is in a fresh water, and it will what decrease the salinity. You can say that decreasing the salinity. Here you can say that evaporation is increasing salinity, precipitation is decreasing mixing of fresh water, river discharge if it is coming, then it is causing, I said that decreasing the salinity. And here we can say that ocean currents distribution is taking place. Ice formation, when the formation of ice is taking place, because of that the salt will come into the ocean, and then it will release the salt, and there will be, you can say that salinity of the ocean nearby will increase. But when the ice is melting, when you can say that when the ice is melting, in this one they will mix fresh water, and there will be salinity will increase. Is it okay? So salinity will decrease. Ice melting causes salinity will decrease. So on the basis of that one, consider the following statement regarding factors affecting ocean salinity. River discharge increases salinity by adding dissolved salt into ocean. So river discharge increases salinity by adding dissolved salt. So you have to check it out whether it is right or wrong. Another one, I said that increased evaporation leads to higher salinity as the water is removed but salts remain there. So you have to say whether it is right or wrong. Another, increased precipitation reduces salinity by diluting seawater. So you have to see which options are correct. Please give the answers. I am waiting for your answers. And next we are going to see horizontal distribution of ocean temperature, and horizontal distribution in this one, if I am talking about the ocean temperature, and if in the, this is an equatorial region, this is an equatorial region, yes, equatorial region, and here 20 to 30 degree or 25 to 35 degree, it is in a subtropical region. And here you can say that this is in a subpolar region, it is in a subpolar region, and there is in a what polar. Similarly, here also we can say that similarly. So what is happening if when the sun rays are there, if I am talking about if the sun rays are here, the sun rays coming vertically in this region, there is a water that the sun rays are coming vertical, and because of the vertical heating in this region, the ocean temperature is more. The vertical heating causes ocean temperature to be more, and in this region you can say there is an what temperature is around 27 to 30 degrees in part of the ocean. And in the subpolar, in this region, what you can say that ocean rays started coming slant, and then heating intensity decreases, and here you can be able to say that around 22 degrees Celsius temperature is there. And further, because and then it is with increasing, and if we are coming into this region, the slanting of the heat is also there, and also there is a mixing of what cold and warm ocean current. This is a mixing of cold and warm ocean current. Because of that also the temperature reaches up to what 10 to 14 degrees Celsius in this polar region. And in the polar region you can say that further sun rays are very less, and in this region very slant, and you can say that it is in 0 to Celsius. So 27 to 30 and 22 degrees Celsius in the subtropical, in the subpolar 10 to 14 degrees Celsius, and the polar 0 to 2. Let us see this thing, and here what we can say that it is in a, and we have, on the basis of that, we have seen that temperature of the ocean is decreasing from equator to what I said, that poles. And here it clearly shows how ocean surface temperature decreases from the equator towards the poles. And in the equatorial region you can say there is a what 0 to 10 between 0 degree to 10 degree latitude. In this region you can say that water is the warmest and maximum insolation, and then there is a maximum insolation, slight cooling in the eastern ocean. If we know that in this equatorial region, you know that the northeast trade wind, southeast trade wind is there. There is a northeast trade wind and there is a southeast trade wind is there, and this is an equatorial. So because of that, if the wind is coming, so there is an upwelling of, on the eastern part there is an upwelling of cold water. This region has an upwelling of water, cold water in the coastal area. So that's what it is saying, slightly cooling in the eastern ocean, slightly cooling because of the northeast and southeast due to the upwelling. Otherwise temperature is 27 to 30 degrees Celsius in this region. Subtropical region, the temperature, this is 20 to 30 degree latitude in northern and southern. It may be sometimes 25 to 35, it is also written. Hot subtropical waters, that is 22 degrees Celsius, often records the high ocean temperatures thanks to the clear sky and subtropical highs. In this region subtropical air is to descend down only, cloud coverage is not there, and then intense heating is there, and slant, intense and slant, the temperature is up to 22 degrees Celsius. In the mid latitude or subpolar low pressure, mid latitude means in subpolar low pressure zone, in this region the temperate waters, a strong seasonal variation, the contrast shaped by the warm and cold currents when they are meeting, and also slanting of the sun rays, making the temperature to be what 10 degree to 14 degrees Celsius. And in the polar region you can say that what very slant, near freezing water temperature is 0 to 2 degrees Celsius, sea ice cover, low solar angle, here it is in a very low solar angle, and at the same time high albedo. Albedo means, I said, that reflecting. Sun rays are coming, striking with the ice coverage, and they keep on reflecting back. The amount of reflection of sun rays from the surface, ice surface, it is known as a albedo, so there is a less heating also. So that's what it is, we can say. And here we can be able to say that in the equatorial region 27 to 30 degrees Celsius, and subtropical region we have seen there is a 22 degrees Celsius, and in the mid latitude or subpolar region 10 to 14 degrees Celsius, and here in the polar regions we can be able to say there is an 80, there is a what 0 to 2 degrees Celsius. And after that the question is here that highest ocean temperature are always recorded exactly at the equator. So you have to say whether it is right or wrong statement. Subtropical regions often record less temperature than equator. That's the third statement. It is talking about temperature decreases uniformly from equator to poles. Please answer this question in the comment box, and I am waiting for your answer. And here you have to answer accordingly. And the next that we are going to see, it is about vertical distribution of ocean temperature. If I am talking about vertical distribution of ocean temperature, and in case of vertical distribution of ocean temperature, In the same way, if we have to talk about like this is in a box I have given, and here it is in a what 200 meter, or you can say that 500 meter in the accordingly some we are talking about 0 to this one, and thereafter till the 1000 meter, and there's in a deep sea. This layer is known as I said that surface. You can say it is in a surface zone or mixing zone. You can say surface zone, and or you can say mixing zone. And in this region, and this is what I said that thermocline layer. It is known as a thermocline layer, and this is I said that deep sea layer. It is what deep sea. According to the vertical distribution of temperature, if we are talking about vertical distribution of temperature. So in the different parts, horizontal distribution we have seen different. From the now it is talking about if I am going downward. So in the equatorial region, if I have said the temperature is suppose 27 degrees Celsius, 27 to 30 degrees Celsius. After that, in this region, you know that the rainfall is occurring, evaporation is happening, the sea waves keep on mixing. So the temperature, whatever the temperature on the top, the still the 100 or 500 meters. Somewhere again I am saying always 200, somewhere it is 500. So if it is given in the UPSC exam 200, you have to consider as 200. Sometimes it is written 500, so you have to write what 500. So that the both are correct. So here till this one the temperature will remain same. Whatever it is the top, it will be remain same, and after that it will start decreasing. It can reach to what I said that 2 degrees Celsius suppose, and because of what thermocline. Thermo means heat. Therm means heat, and cline means incline means decline. So there is a rapid decrease in temperature. Here it is in a what you can say that rapid decrease in temperature. The rapid decrease in temperature which is taking place, therefore it is known as a thermocline layer. As it in the ocean salinity we have seen there is in a what halocline layer. The same way here it is in a thermocline layer, and after that thereafter there will be what you can say that as in a temperature will be in the region of 0 to 4 degrees Celsius. In this one somewhere 2 degrees, somewhere 1 degree. So here it will be remain constant kind of things. So you can say it is in a decline, it is in a what, it act as a barrier between top and down. Now this kind of thermocline layer, it is more visible in more visible in what equatorial region, because in the equatorial region the temperature is good throughout the year. So the top will be what I said that 27 to 30, and below there is not suddenly temperature decreases, thermocline, and thereafter deep sea. But if we are going to the temperate zone in the mid latitude, during the winter whole water is colder, 10 to 14, above it is 10 to 14, that the below 10 to 14 in thermocline, and then in the winter 10 to and 0. So I said that there is no thermocline layer exists during winter in the mid latitude. So if I am talking about in the mid latitude, you can say that it will be no thermocline layer. So more visible thermocline I am talking about. And but in the winter it is not visible, and in the summer thermocline layer is visible in the mid latitude, and in the polar region throughout the year there is no thermocline layer. In the polar region thermocline layer does not exist. Thermocline layer does not exist in the polar, because the top cold 0 to 2 degrees Celsius, and the till down it is 0 to 2 degrees Celsius, whether it is summer, whether it is in a winter. So thermocline layer, it is an important part for this one. Therefore I have discussed with you, I said that what is this surface or mixed layer? It is 0 to 200, warm, well, mixed, phytoplankton, seasonal changes are there. Yes, that I have said that is in a sum. And the thermocline means rapid temperature drop, means a transition zone, and in this one temperature rapidly decreasing. In the deep ocean it is in a cold and a dark condition, it is there, cold and you can say that dark, and the temperature it will be very 0 to 4 degrees Celsius, and in this region the pressure of water is very high. So here you can say that vertical distribution thermocline layer, whatever I have discussed, the same thing is over there. A zone of rapid from the 200 to 1000 you can say, or 500 to 1000 you can say, there is a zone of rapid decrease in the temperature with increasing depth. What is the important part of this? That it acts as a transition layer between warm surface and cold deep water. So warm surface layer is a warmer and deep, so it is act as a barrier in between. It is okay. So transitional layer, and then temperature drops sharply from the 20 degrees Celsius. Suppose in the top it is 20, then it can go up to the what 5, means a high change in temperature in the what thermocline layer. So here thermocline is a permanent, found in the tropical oceans, means equatorial region, strong and well developed, exists throughout the year. But if I am talking about in the temperate regions or mid latitude regions, it is found in mid latitude region but develops in summer but disappears in winter. And there is an absent thermocline or weak in the polar region due to the informally cold water. So importance is that that thermocline layer is act as a barrier between vertical mixing with the lower. What is some question based on it? I said that consider the following statement regarding the thermocline. It is a layer where temperature decreases rapidly with the depth. You have to answer whether it is right or wrong. And it is in a strongest, second statement, it is the strongest and permanent in tropical regions. And then third, it allows free vertical mixing of nutrient between the surface and deep water. Does it allow any mixing? So please, accordingly, you have to answer it. So we are waiting for your answers. So please give your answer in the comment box. Next one, factors affecting ocean density. The two things are there, factors affecting ocean density. You can say that there is a salinity, and then what I said, that temperature. If I am talking about temperature, so if I say that temperature means, if I say that if the temperature of water is colder, less temperature, the cold water is compressed. And the cold water compressed means the density is more. And then warm water is expanded one, therefore density is less. Simple. The cold water, it's just so easy. So if we'll say that in equatorial region, in subtropical region where the temperature is more, the density of water is less. And if I'll go into the polar region, in the colder region where the density of water is high because the temperature is very less. So we can say that you can say that if the more temperature, less density, means inverse relationship. You can say that, and if the what I said that high temperature, low density, and the temperature is low, means colder, density is what? High. So we can say that inverse relationship. You can say that there is an inverse relationship between temperature and density. Low temperature in the polar region, therefore density is high. And you can say that in the polar regions, high density water, and equatorial region, low density, you can say. And where the temperature is more, the density will be what I said, that less, that I have discussed with you. Explanation: cold water molecules are closely packed. Cold water, it is a very closely packed, compressed one, therefore density is high, higher density. And then we can say that warm water expands, they expands, and then temperature is more, therefore density is less. So the temperature based. And another that we have to see also. And then what is the density? Density means what? Mass per unit volume. Density, all of you know that. What is the meaning of density? Anywhere, mass per unit volume. So what is the, in 1 unit volume, what is the total mass of water, and along with water, what are the salinity, whatever it is there. So in 1 unit volume, in particular volume, whether the mass is increasing, you can say that the density is more. In a particular volume, mass is decreasing, then you can say that density is less. And then density means mass per unit volume of the seawater. Average, it is what? 1.020 to 1.030. Must remember this one. Probably it can be asked gram per centimeter cube. Now, if I am talking about salinity, so what is the relation between salinity and density? If I am talking about, if in ocean salt is more, if in ocean salt is more, the density of water is more. If the ocean, if the salinity, suppose I said that salinity is 34 parts per thousand. So 34, and another ocean salinity is suppose 37 parts per thousand. So that water has more density, which has more salt in the water, and those water which, as I said, that ocean water has a less salinity, means less density. Here it is a direct relationship. More salinity, more density, less salinity, less density. So here you can say there is a direct relationship, more salinity, more density, less salinity, less density. So here dissolved salts increases mass without much increase in the volume. So here you can say that Red Sea, yes, Red Sea has around 40 parts per thousand salinity.
So it has a high salinity. Mediterranean Sea has 39. It has a high salinity, high density. In the Persian Gulf, around 41. So Baltic Sea, you know that in the between one country is there, Sweden and Finland in the Europe. In that region, Baltic Sea, and then some European countries are there. So in that it is in a 20 parts or sometimes 22 parts per thousand. Salinity is less because of mixing of fresh water. And if there is in a water because of what you can say that if there is a salinity is less, its density is less. So the low density we can say, and this is in the colder region higher density we can say, and in the warmer region density is lower. Yes or not? Because the warm water is more expanded. So and in the salinity, higher salinity, high density you can say, and in this region lower salinity will be low density. Is it okay? And now consider the following statement regarding ocean water density. Ocean water density decreases with decrease in temperature. It is talking about ocean water density decreases with decrease in temperature. Yes, whether it is right or wrong, we have to say. I have said it is in a which kind of relation. Salinity has a direct relationship with the density, second statement. And then third statement, water, warm ocean water is denser than the cold ocean water. Warm ocean water is colder. So you have to answer this question accordingly, and I am waiting for your answers. Now another one, we are going to see another. For this question we have to understand then one part. It is very much important that here it is in a specific heat. A specific heat, it is talking about a specific heat. It is talking about the amount of heat required to raise the temperature of 1 kg of water. So you can say that it is in a 1 kg of water is there, and another it is, I said that 1 kg of land is in a 1 kg of land. So when I have supplied heat, 1 kg of this is in a water. When I have supplied heat, what I said that 100 calorie, then 200 calorie, then 300 calorie, then 400 calorie. When I said that 400 calorie heat I supplied, I said that its temperature increased from 14.5 to 15.5 degrees Celsius, and that is means 1 degree Celsius rise in temperature by 400 calorie. Is it okay? And you know that when I supplied heat to the water, land, only 100 calorie, its temperature has been, what I said that increased by, you can say that its temperature is increased by 14.5 to 15.5 degrees Celsius. Means 1 degree Celsius increased only by 100 calorie. But the sun says I am giving heat to the same. Sun is saying that I am giving heat same to the, what I said that water and to the land. And if I am giving everywhere 400 calorie, and this is in a 400 calorie, so what will happen that the temperature of the, what I said that water will be only 1 degree Celsius because of 400, and but if I am giving 400 to the land temperature will become 100 calorie, 1 degree Celsius. So we can say that by 400 it will be 4 times more 4 times. So it will increase from 14.5 to 18.5 degrees Celsius. So land is more heated because of the low specific heat. It is a low specific, it has a water has a specific heat is 4 times less than what we can say that a specific heat of water. Land has 4 times less specific heat, and water has more high specific heat. And we can say like water, if you can say that water has 4 times more specific heat. And if it has a more specific heat, what I said that it takes longer time to get heat up. It takes longer time to get heat up. Yes or not? So it takes large time, means 1 hour, 2 hour, 3 hour, 4 hour. But ocean and the land in the 1 hour it will heat up, because specific heat is low. So if water has 4 times more specific, it means higher specific heat, and any substance has higher specific heat, you can say that it takes longer time to get heat up. Yes or not? And we can also say that it takes you can say that very what I said that longer time to release the heat to become colder, to reduce the temperature. It takes longer it takes, you can say, longer time to release the heat to reduce temperature, So what we can say that it takes longer. If the specific heat of any substance is higher, it takes absorb the heat very slowly, and it what I said that release the heat very slowly. So it is about the what we can say that specific heat of higher. If the specific heat is, you can say that it is in a low specific heat. If it has a low specific heat like land has what I said that low specific heat, 4 times less. It is in a land is what I said that low specific heat, 4 times less than the water. It absorbs the heat fast. And you can say that when there is a sun is there, it will absorb the heat fast, and you can say that when it has to, what I said that winter time, it releases the heat very fast, because winter time sun rays are coming very less, and it releases the heat very fast. Means it is in a 4 times faster than the land water body. So the land will be 4 times faster, absorb the heat fast in the what I said the summer, and in the winter 4 times faster it will release the heat fast. So this concept is very much required. Now I have to see what is the meaning of isotherm. If I am talking about isotherm means, you can say, like I said, that it is an imaginary line joining the same temperature on the earth. Generally I said that we measure it on the map of the world. In the map of the world we are showing it. Suppose this is in a 20 degrees Celsius, it is in a 20 degrees Celsius, it is in a 20 degrees Celsius. So that 20 degrees Celsius, so when we'll join this one, this is known as what you can say, it is an isotherm. It is an isothermal line. Is it okay? Isothermal. So now if I talk about this is in a map of the world. In the map of the world, if you are watching during the January month, you know that in the January month it is in a winter period. In the January month, you can say it is in a winter period, very cold temperature in the northern hemisphere. And here, suppose the temperature in this region, here there is in this region, the land in this European region, here the temperature is 0 degrees Celsius. This region, here it is you can say 0 degrees Celsius. Here it is in a 0 degrees Celsius. Here it is in a 0 degree. And in the ocean, you know that it is in a this region will have a 0 degree, because I have already told you in the polar region. I said I was talking in this video itself that in the polar region there was, and I said that the temperature is 0 to 2 degrees Celsius. In this 0 to 2 degrees Celsius, and thereafter in the land the temperature it will be 0 here, and in the land temperature is 0 here, 0 here in the month of January. And what we can say that if I join the line, it is you can say that this is your isothermal line. This is what we can say that it is an isothermal line, and in the isothermal line you can say that it is bending towards equator. It is a bending towards what you can say that equator or southward. You can say that bending towards equator or southward over the land. So over the land it is bending towards equator or southward, and in the ocean it is, I said that bending towards north, bending towards north, or we can say that poleward in the over ocean. In the ocean northward, you can say that or poleward, and in the January month, because this kind of things you can be able to see. Is it okay? And at the same time, if I am trying to say, like I say that if I say like this is the one thing that we have seen. Now if there is a 0 degree temperature is there, if there is in a what in the January month, if I am talking about, I said that winter is there, yes or not? In the winter is there, and there is an also summer is there. So if I am talking about, yes, we'll come on to this one now. Let us see some question based on it. And here we can say, like I say, here it is in the UPSC 2025. This question has been asked. We have to answer it, and I'm waiting for you to answer the statement 1. In January, I am talking about in January, in the northern hemisphere, the isotherms bend equator what? While crossing the landmass. Yes, tell me. In the northern hemisphere, the isotherms bend equator-wide while crossing the landmass, and poleward while crossing the oceans. Yes, you can see what is there. Yes, you can be able to say that. On the basis of that, you have to try to see. In January, the air over the ocean is warmer. In January, the air over the ocean is warmer and than over the landmass. If I am talking about we can say that suppose here the temperature is in this region, suppose 0 degree temperature. It is in a 0 degree temperature. If I am talking about this is your what 0 degree temperature, but in the ocean in this region there will be what I said that 12 degrees temperature. In the same reason, because the water of the ocean will be relatively warmer and the land will be colder because it will release the heat fast. So it will be 12, it will be 0. So the air above the ocean will be what? Warmer, and the air above the land will be what I said that. So it will be land over, it is in a 0 degrees so colder, and if I am to measure the 12 degree isotherm, it will be like that. Yes, any temperature measurement is there, this kind of it. So we can be able to say if in at the same region, measurement warmer or colder in the same region, it will be not far away. So what we can be able to say on the basis of that, this question you can answer, in January the air over the ocean is warmer than that over the land masses in the northern hemisphere. So accordingly, you have to answer this question, and I am waiting for this question. Another part that we can say here, like I said that which of the following are correct inference or inferences from the isothermal maps in the month of January, UPSC 2024, it has been asked. The isotherm deviate to the north over the ocean. It is talking about deviate to the north over the ocean and to the south over the continent. Is it the same kind of question, but the word, instead of I said that north south, in the north earlier it was a pole word, now it is north, and equator word it is said south. So in the isotherm deviate to the north over the ocean and to the south to over the continent. Now tell me whether it is a right statement or wrong. So please accordingly answer it. I am waiting for it, and I will answer this question in the next episode. The presence of cold ocean current, Gulf Stream, North Atlantic drift make the North Atlantic Ocean colder. If I am talking about, I said that the cold ocean current, Gulf Stream, North Atlantic drift make the North Atlantic Ocean colder, the isotherms bend towards the north. So you should have an idea of a Gulf Stream. You know that Gulf Stream is in a warm ocean current. North Atlantic is in a what? A warm ocean current. You need to know. These are not the cold ocean currents. These are not the cold ocean currents. Gulf Stream is in a warm moving on the eastern part of North America. So whether this statement is correct or wrong, so accordingly you have to answer it. Another part that we are going to see in 2023, the question has been asked, the temperature contrast, statement 1, the temperature contrast between continents and ocean is greater during summer than in winter. Temperature contrast. And then the temperature contrast, if I am talking about temperature contrast, if I am talking about, it is in a winter, and here you know that in this question it is talking about, yes sir, that the temperature contrast between continent and ocean is during summer is more than winter, and what we can say that here more than here it is in a 12 degrees Celsius, but in the summer what will happen, here will be again, it will be around 12. It will be in the what you can say in this, it is in the winter. January means winter. And if I talk about in the summer's time, the land absorb the more heat, yes or not? And it will be, you can be able to say that is in a what, it is in a 20 degrees Celsius. If the land is there 20 degrees Celsius, then the ocean in this region will be what I said, that's 17. So ocean that time temperature will be less in the summer because the land absorbs more heat, and the temperature contrast is, you can say that only 3, and in the winter there is no so much high. So you can say accordingly you can answer this what you can say that this question. And this is the first statement, the temperature contrast between continent and ocean is greater during summer. We have to see whether it is right or wrong than in winter. Statement 2, the specific heat of water is more than that of the land surface, whether it is right or wrong. So please accordingly you have to answer this question. I am waiting for your answer, and for this one this way we have finished with this. And please answer every question in the comment box. I will see your answer, and we will meet again in the next 7th episode. Till now.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.